Dear colleagues, hard cataract with leathery posterior plate. A stubborn leathery posterior plate is a challenge to many of us. But it is not difficult at all to manage such cases. We just have to apply our common sense to manage such cases. Nuclear sclerosis in this case will be about grade 4. And whenever there is a hard cataract, I always do a large rhexis, and so that I can see the rhexis where it is going properly, I always stain the anterior capsule with trypan blue dye in hard cataracts. So the dye has been washed out. Now I'm going to inject viscoelastic substance. In this case I am using hydroxypropyl methyl cellulose, but in such cases soft shell technique is a good idea, where you inject a dispersive viscoelastic substance first, and beneath that dispersive viscoelastic substance you inject a cohesive viscoelastic substance. Now I'm doing capsulorhexis. I incise the capsule with, there is some jonular weakness, so I have to be very cautious in this case. So I'm doing a rhexis now with Utrata forceps, and I am doing a rhexis of adequate size. I want to do a rhexis of about 6 mm, so that nucleus management becomes very easy. I'm going very slowly because I saw some amount of jonular weakness in this case, not much, but some amount of jonular weakness was there, and I thought I will be able to manage this case without using any capsular tension ring. Now I am doing hydrodissection at multiple points. Small amounts of fluid is injected, the nucleus is depressed and it is rotated. Viscoelastic substance is injected again. Since the cataract is not very hard, I am going to do direct chop by a technique which I call submarine chop. What I do is I bury the tip into the substance of the nucleus, travel through the substance of the nucleus, keeping the tip buried, and I ensure that I am going through a deeper plane, and as I reach the opposite equator I chop it. Do some more scalped. So this is actually trenching and chopping at the same time. Now see, this is again, the tip is totally buried, it travels through the substance of the nucleus, and then the big fragment is chopped. Now it is getting cracked peripherally, but centrally the pieces are attached to a leathery posterior plate. I scalped it and tried to separate the two pieces, but I could not. So what I do is I do some more cracks in the nucleus. And this is the larger heminucleus. These two heminuclei have not been of equal size, and this is the smaller heminucleus, and this has divided into two parts. I've come out. I want to inject some viscoelastic substance, and then I want to see if the leathery posterior plate can be broken manually. So I take a Sinskey hook and a chopper, and I find that this fragment is free, but there is some attachment here. Yes, so two fragments, two heminuclei has separated from each other, and there is a large free fragment. This fragment is free from the rest. So after some manual work, I again go into the anterior chamber, and I want to emulsify the piece which is above the other pieces, this one, and I am catching the apex of this fragment first and then emulsifying and removing it. Here this fragment is also free. I hold this fragment again at the apex and emulsify and remove it. The machine being used is Oatley Catrix 3. It's a peristaltic system, but it is quite fast. And now see what I'm going to do. These three, four fragments are joined here at this point, and I have attacked that point, and all the fragments are free now. So with the phaco tip, we can break the leathery posterior plate. We just have to apply a little bit of energy to the point where all the pieces are attached. That is, near the apices of all the fragments. Now this fragment, since there was some amount of jonular weakness, and I saw that the posterior capsule is very near to the phaco tip, inject some viscoelastic substance and push the posterior capsule towards the vitreous cavity. And now I want to emulsify these two fragments single-handedly so that leakage from the side port stops. The antechamber remains more stable. I just place the pieces in convenient position and come out, and this is the last bit of nucleus. That's it. The nucleus and epinucleus has been managed. Now I inject some viscoelastic substance, and in this case there was only one side port, and I have used a Simcoe cannula to remove the cortical matter. There are some fibrous tissue kind of thing on the posterior capsule. After injecting viscoelastic substance, in this case I am implanting a hydrophilic acrylic intraocular lens, and since the lens is dialed and it is placed in the bag, since I have used viscoelastic substance, I am going to spend a lot of time to remove the viscoelastic substance. In this case I could have probably managed without viscoelastic substance, but since the jonule was weak, I didn't take any risk. And now I am removing the viscoelastic substance from the capsular bag and from the anterior chamber. So from this video, what I want to emphasize on is it is not difficult to conquer a leathery posterior plate. The fragments are attached to a leathery posterior plate centrally. If we can divide the nucleus into two heminuclei, we can attack the point of joining where all the fragments are attached. We can attack that point with the phaco tip, and we can break that point, and all the pieces get separated from each other, and emulsification of the fragments become very easy after that. After cleaning the viscoelastic substance, this is a little bit of moxifloxacin. I don't depend on moxifloxacin. This is just moxi lavage. I have injected moxifloxacin. Now I hydrate the side port, and few seconds the moxifloxacin is there in the anterior chamber, and this is the final lavage. This time I remove whatever I have used, moxifloxacin and the final bits of whatever viscoelastic substance I can remove is removed by this final anterior chamber lavage. Anterior chamber is formed and the case is concluded. Thank you very much for watching. Hope this video will help you in your practice.